You are lying on your back roughly 20,000 years ago on a cold patch of ground somewhere in Ice Age Europe. The fire has burned low, and above you, stretched across the entire sky, is something you look at every single night: the stars. You don't have a clock, you don't have a calendar, you don't even have a word for Tuesday, but you've noticed something. The moon changes. It swells up fat and round, then shrinks down to nothing, then comes back, over and over, always the same. And the sun? It rises over that hill, then a little further, then a little further, until one day it stops, turns around, and walks back the other way. Something out there is keeping a rhythm, a beat, a pulse that never, ever misses. And you're starting to realize you can count it. That moment, that first spark where a human looked up and thought, wait, this is happening on a schedule, is one of the most important ideas our species ever had. Because time isn't a thing you can touch. You can't hold it. You can't see it. You can't put it in a bag and carry it home. And yet somehow, ancient humans figured out how to measure the one thing in the universe that has no edges. So how did we go from staring at the moon to atomic clocks that don't lose a second in 15 billion years? And listen, before we go back 20,000 years, do me one tiny favor. If you're the kind of person who's ever laid awake wondering how any of this stuff actually works, hit that like button and subscribe. Seriously, it takes 2 seconds, it's free, and it tells YouTube to show this to more curious people like you. That's it. That's the whole ask. Okay, let's get into it. Here's the thing you have to understand. The first calendar wasn't invented, it was noticed. Ancient humans didn't sit down and design time. They watched it. And the sky handed them 3 perfect repeating cycles for free. The day, sun up, sun down. The month, the moon, growing and shrinking. And the year, the slow march of the seasons, cold to warm and back again. 3 natural clocks ticking away in the sky whether anyone was watching or not. And people were watching, way earlier than you'd think. There's a bone. It's called the Ishango bone, found in what's now the Democratic Republic of Congo, and it's around 20,000 years old. It's covered in carved tally marks. And some researchers think those marks line up with the phases of the moon, a lunar calendar scratched into bone tens of thousands of years ago. Think about that. Before farming, before cities, before writing, somebody was already keeping score of the sky. But here's the real question. Why? Why would a hunter-gatherer care what day it is? And the answer is survival, pure and simple. If you know the seasons, you know when the herds migrate. You know when the berries ripen. You know when the river floods. Time wasn't a philosophy problem for these people. It was food. It was the difference between a full belly and a slow winter death. And then farming showed up around 12,000 years ago, and time got even more serious. Because now you had to know exactly when to plant. Plant too early, frost kills your crop. Plant too late, it never ripens. Your entire village could starve because you misread the calendar. So suddenly, knowing the date wasn't a nice to have. It was life or death for everybody. Nobody felt this pressure more than the ancient Egyptians. Their entire civilization ran on one event: the flooding of the Nile. Every year, the river swelled and dumped rich black mud all over the farmland. Miss the timing and you missed the whole growing season. So the Egyptians became obsessed with predicting it, and they cracked it in the most beautiful way. They noticed that right before the flood came, a specific super bright star, we call it Sirius, appeared on the horizon just before sunrise, after being invisible for months. The star showed up. Then the river rose every single year. So they built a calendar around it, 365 days, 12 months of 30 days, plus 5 extra festival days tacked on the end. Sound familiar? That's basically our calendar. The Egyptians nailed the length of the year over 4,000 years ago just by watching a star. Okay, so they had the year, but what about the day itself? How do you chop a single day into pieces? The Egyptians did that too, and this is where those weird 24 hours come from. They split daytime into 12 chunks and nighttime into 12 chunks, 12 and 12. And that's not random. A lot of ancient cultures love the number 12 because you can count it on one hand, using your thumb to tap the 3 segments of your other 4 fingers. Try it right now. 4 fingers, 3 bones each, 12. And to actually track those hours during the day, sundials, a stick in the ground. As the sun moves, the shadow moves, and you read the time off the shadow. Simple, genius, and completely free. But sundials have one obvious, embarrassing flaw. The sun goes down. At night, on a cloudy day, your fancy shadow clock is useless. You're back to guessing. So people needed a clock that didn't depend on the sky. And they came up with something clever. They used flow. The water clock. You take a bowl, poke a small hole in the bottom, fill it with water, and watch it drain. The water level drops at a steady rate, so you mark lines on the inside and boom, you can tell how much time has passed. Day or night, rain or shine. The Egyptians used them, the Greeks used them, the Chinese built absolutely massive, incredible versions. Water clocks ran the world for thousands of years. And there was another version of the same idea. You already know this one. Sand. Flip the glass, watch it fall, and when it's empty, a set amount of time is gone. The hourglass. Same principle, different material. But water and sand had their own problems. Water freezes. Water evaporates. The flow speeds up when the bowl is full and slows down when it's nearly empty. It worked, but it was never really precise. Humans wanted better. Humans always want better. And then, in medieval Europe, everything changed. Somewhere around the 1300s, in the monasteries and towns of Europe, people built the first mechanical clocks. No water, no sand, no sun. Just gears, weights, and a clever little device that released energy in tiny, even bursts. This was huge. For the first time in human history, time was no longer coming from nature. It was coming from a machine that ticked the exact same way at noon, at midnight, in summer, in winter, forever. And they stuck these clocks on giant towers in the middle of town, so the whole city could hear the bells and live by the same time. That's actually where the word clock comes from the old word for bell. But here's the wild part. These early clocks were terrible at keeping time. They could lose 15-20 minutes a day, which is exactly why most of them only had one hand, an hour hand. A minute hand would have been a joke. The clock wasn't accurate enough to even bother pointing at the minutes. The fix came from one of the greatest minds who ever lived. The story goes that a young Galileo was sitting in a cathedral, bored, watching a lamp swing back and forth on its chain, and he noticed something nobody else had. No matter how big or small the swing, it took the same amount of time to go back and forth. The rhythm never changed. That's called a pendulum, and it is nature's perfect metronome. Galileo figured out the science, but it was a Dutch inventor, Christian Huygens, who put a pendulum inside a clock in 1656. And the improvement was insane. Clocks went from losing 15 minutes a day to losing about 15 seconds a day. Overnight, they got 60 times more accurate. Now, the minute hand made sense. Now, the second hand made sense. For the first time ever, ordinary people could care about minutes. The pendulum didn't just improve clocks. It reshaped how humans experienced their own lives. But there was one place a pendulum clock was completely useless: the ocean. And this was a massive deal, because sailors had a deadly problem. They couldn't figure out their east-west position at sea. Ships were smashing into rocks, missing islands, and getting lost, killing thousands of people and losing fortunes. And the crazy thing is, the solution was time. If you knew the exact time back home and the local time on your ship, you could do the math and know exactly where you were on Earth. The whole problem came down to one thing: carry a perfect clock across the ocean. But a pendulum can't swing straight on a rocking, pitching ship. So it was impossible. Britain was so desperate, they offered a giant cash prize, a fortune, to anyone who could solve it. And the man who cracked it wasn't a scientist or an aristocrat. He was a self-taught carpenter named John Harrison. He spent decades of his life building a sea clock that used springs and balances instead of a pendulum. And it worked. His clock kept near perfect time across an entire ocean voyage. One stubborn carpenter, obsessed with time, quite literally changed the map of the world. Now here's something that'll surprise you. For almost all of history, every town had its own time. I'm serious. Noon in your town was just whenever the sun was highest over your town. So a city 50 miles east was a few minutes ahead of you. And nobody cared. Why would they? You never talked to those people in real time anyway. And then came the trains, and everything broke. Because suddenly you had train schedules, and every town having its own clock made the schedules total chaos. Trains were nearly crashing because two stations couldn't agree on what time it actually was. So in the 1800s, the railroads forced the issue, and the world got carved up into time zones, big slices of the planet that all agree to use the same clock. Time stopped being local. For the first time, a whole country, and eventually the whole planet, got on the same page. Which brings us to today, and clocks so accurate they almost don't sound real. Modern atomic clocks don't use gears or pendulums or water. They count the vibrations of atoms. And atoms vibrate at a rate so unbelievably steady that the best atomic clocks won't lose a single second in billions of years. Not decades, billions of years. Longer than the Earth has existed. And you use them constantly, even if you've never seen one. Every time your phone shows you a map, it's talking to satellites with atomic clocks on board. GPS is literally just clocks in space. It figures out where you are by measuring tiny, tiny differences in time. Differences of a few billionths of a second. Read that again. The thing that tells you where the nearest coffee shop is, it runs on time so precise, a human could never even feel it. So think about the journey here. We went from scratching moon phases onto a bone, to a stick casting a shadow, to water dripping through a bowl, to gears in a tower, to a swinging lamp in a cathedral, to a carpenter's ocean clock, to atoms humming in a lab. Thousands of years of humans chasing the exact same thing, trying to catch something they can't even touch. And that's the strange, beautiful truth about time. We didn't invent it. It was always there, ticking in the sky, long before we showed up, and long after we're gone. All we ever did was learn to listen to it. Tonight, somewhere, there's a clock on a wall. You probably won't even glance at it. But that quiet little tick is the end of a 20,000-year story. A story that started with someone lying on the cold ground, staring up at the moon, and daring to count. They just knew the moon comes back, and the sun turns around. And time, whether we watch it or not, keeps the beat.